So today we are talking about another conic, which is an ellipse. An ellipse comes from when you take these two cones and you slice through one of them, kind of at a diagonal. So it's going to kind of form like an elongated circle. And this is another example of how we can draw an ellipse. So if you take these 2 points here that we call a focus, and you kind of put a string attached to each of those, and then draw around, that will give you a perfect ellipse. So here's a picture of what an ellipse would look like on an X and Y axis. This is with kind of the center here at 0, 0, or at the origin. The width of the ellipse that's longer is called the major axis. So here this would be your major. And the Y on this one would be your minor. And then when our ellipse is kind of tilted the other way, what we would call vertical, this is your major axis, and this would be your minor. Okay, so what we have here now is this is the equation of an ellipse. And this is when our center is at 0, 0. So this A and B is like representing the lengths of those major and minor axes. So your major axis is on the x-axis if A is greater than B. So if the A value is greater than B, then it's along the x-axis. If the B is greater than A, then it's along the y-axis. So the B always gets grouped with the y squared, and the A always gets grouped with the x squared. So whichever one of those is larger is where your major axis is going to be. So here are the steps to graph an ellipse. We want to write it in standard form, which is this form here, if it's not already. Determine which one is the major axis, the horizontal or the vertical. Find the endpoints of each of the axes, and then you're going to sketch it. So let's look at what some of those problems might look like. Okay, let's take a look at example 1 here. So example 1, we are in what we would call our standard form. I might want to take this just a step further and say, write those A and B values as squared. So now which axis is our major axis? That would be the 3. So it would be the y, or our vertical would be a vertical major axis. So our x-axis, or our x-intercepts, are going to be at 2, 0, and negative 2, 0, and our y is at 0, negative 3, and 0, positive 3. So we're going to plot those. And there is your ellipse. Now our second one here, we're not in standard form right now because it's equal to 16. So what I need to do is divide everything by 16. And then let's go ahead and simplify this stuff and turn it into squared. So those denominators, I'm going to write them as a version of something squared. So what this would be then a 4 on the bottom. So I could make that a 2 squared, right? So now my major axis is my x-axis. It has points of 4 and negative 4. And then my y-axis is my minor axis. It has points of positive 2 and negative 2. And there is your ellipse. Okay, example 3 here. So what if we give you the picture of the ellipse and we ask you to write the equation? Well, we can start with this when it has the center is at the origin at 0, 0. And then on this, looks like my major axis is a 4, right? Along the x-axis. So that's going to be 4 squared. And then my minor axis is 3 squared. So when we're asked to write the equation like this, we want to actually square those out. So it would be x squared over 16 plus y squared over 9 equals 1. Okay, so you can probably guess we don't always have an ellipse with the center at the origin. So this is the equation, how it changes just a little bit when we have the center not at the origin. So this is with a center of HK. We'll put H and K in with our X and Y squareds. So the formula has this subtraction in the middle. So kind of like we were doing with the vertex to the parabola. But now both of these, when we pull them out, will have to change their value to kind of the opposite of what we see there. But otherwise, graphing this is pretty much the same. Okay, so let's look at our first example here. It's already in standard form. So I guess the first thing to pick out would be, where is your center? So that's your HK, or the numbers that are being subtracted from the X and the Y values. So here, it's going to be the 0.31. So that's going to be basically the center of our ellipse. Now, the 9 would have been, it came from a 3 squared, right? And the 4 came from a 2 squared. So I'm just, instead of rewriting them, I'm just going to kind of cross them off there. So this means that our major axis is along, it's horizontal, kind of like along the x-axis, but now it's not the x-axis, it's just horizontal. And this number here, the 3, is going to tell us how far we go on each side of that center. So from the center, we're going to go 1, 2, 3, 1, 2, 3. And then the other number, 2 squared, so that 2, we're going to go 2 above the center, and 2 below the center. Sketch your ellipse. Okay. Okay, so the next one says sketch by translation. But what I want you to do, just use the same method I just used on the last one and sketch that. So I want you to go ahead and do it. Put this on pause and sketch it yourself. Okay, so your center here should be at -4, 6, -4, +6. The length of your major axes would be 4. The length of your minor axes would be 3. Now, when they asked us to do it by translation, what they wanted us to do was graph first x squared over 16 plus y squared over 9 equals 1, which would have been this ellipse at the center, which would be 4 to each side, and then up and down 3. And then from there, these numbers here can tell us how much we have to move it. We had to move it to the left 4 and up 6. So whichever way you want to think about it. Okay, example 6 here. What if they don't give us the equation in really a nice form at all? So if I'm looking here, I have some x values, some y values, and a constant. So what I'm going to need to do is I'm going to need to do that completing the square. I'm going to do it on my x values, and then I'm going to do it on my y values. So the first thing I'm going to do is I'm going to kind of rewrite this as x squared minus 4x plus 4y squared plus 24y plus 24 equals 0. And then each of these parentheses here, I'm going to do the work to complete the square on it. So what do I have to add in here, and what do I have to add in here? Now remember, whatever you add into those, you also have to, since we're working on the same side, you would also have to subtract it. This one we need to divide out a 4 first. So go ahead, take a minute and see what work you can do on completing the square there. Okay, so let's look at the x. So it would be -4 divided by 2 squared. So that would be -2. So I'm going to add 4 to each side, -2 squared. So, oops, that has to be subtraction there. So if we're adding a 4, then we also have to subtract a 4. Here, I need to divide a 4 out of here first. I'll just kind of rewrite it a little bit. So I'm going to do 6 divided by 2 is 3, and square it would be 9. So I'm going to add a 9, but I'm really adding 36. So I also need to subtract 36. Okay, let's go ahead and write those each as a perfect square. So that would be x minus 2 squared plus 4 times y plus 3 squared And that's going to be minus 16. So now I'm getting closer. So I'm going to move this 16 to the other side. And I could have probably done that back in the beginning. We could have moved the 24 to the other side, made it negative 24, and then every time we added something to this side, we would add it to the other side. So whether you do it first or at this stage doesn't really matter. But we now need this to be a 1. So I'm going to divide everything on both sides by 16. So we'll have x minus 2 squared over 16 plus y plus 3 squared over 4 equals 1. So could you go ahead and write down what the center would be and graph that, please? Okay, this is what we should have. So we should have gotten that the center was at positive 2, negative 3. Our major axis has a length of 4, and our minor axis has a length of 2. Our ellipse looks a little lopsided, I think, but you guys good? Okay, that's it.